So beginning today's class, we are going to try an example of blinking an LED using a microcontroller. So to do this, because this is microcontroller programming, before you can get your system to work, you'd first have to build your electronic circuit. We'll go to schematic capture in Proteus, and from there, we'll start building our circuit. So what we want to do is to blink just a single LED. So we are going to connect that LED to the pin 13 of our microcontroller. So to do that, first we'll have to select our microcontroller. I'm going to click on P on my keyboard, or you can also click on P, and this window should open. So with this dialog box, we are going to type Arduino, and we'll select the Arduino Uno because it's the most commonly used Arduino board. And I'm also going to type LED green because green is a variant of my favorite color. So I'm going to select green. You can choose any other LED you want, but I am using green for this class. And then we'll select one last component, that is our resistor. So I'm going to select the resistor as well, and I'll close this dialog box. I'm going to select the Arduino Uno, click once to have it hovering with my cursor, and then I'll click once again to drop it. Then I'll select my resistor, and then I want to connect it to pin 13. So I'll click once, align it with pin 13 as much as possible, and then drop it. Then I'll select my green LED, click once, and drop that also. All right, so I'm going to connect my component to each other. Just move your cursor to the end of a component. You see a red square highlight. Click once and you would have your cursor moving with this line. Move to the other end where you would like to drop, and then click once again to drop it. It's as simple as that. Connecting components in Proteus couldn't be any easier. So once again, you move it to the end of the component, you click once. After getting your wire to move around along with your cursor, you click once again at the other end, and then you drop it. So I'm going to go to my terminal tab, okay, and then select the ground pin, and then I'll click once again, align it as much as possible as I can, and then I'll connect it. All right, so our electronic circuit connection is ready, and now the next thing we would have to do is to program our microcontroller using the Arduino IDE software we installed earlier. Before that, in microcontroller programming, even if you have your code working properly or with no errors and the logic is intact, and you have issues with your electronic circuits, your desired circuit simulation is not going to be seen, okay? So always make sure your component values are correct and every connection in your electronic side of the circuit is intact. All right, so here we are using a 10K resistor, which isn't good because the microcontroller outputs 5 volts at the digital pins. So to turn the LED on, we'll need about 2.5 volts to turn the LED on. So we are going to use a 220 ohm resistor to drop the voltage so that we do not damage our LED. All right, so now we are done with our circuits. Let's switch to the Arduino side and program our microcontroller. The first thing we want to do in programming our Arduino is to assign variables to the pins in which we are using. For now, we are using the pin 13 and we've connected it to an LED pin. So I'm going to give it a descriptive variable name. I'm using an integer type variable because the pin we've connected to is 13 and 13 is an integer. So I'm going to call this variable LED pin, and I'm going to assign it to pin 13. All right, so for now we are done with declaring our variable, and because the microcontroller has general purpose input output pins, we'll have to specify to the microcontroller that we are actually using pin 13 as an input pin or an output pin. How do we do that? The decision is dependent on the type of component you are connecting to the microcontroller. This time, we are connecting an LED pin or an LED. So connecting an LED. An LED is an output device. Why? Because it is going to take signals from the microcontroller and display information to the outside environment by either turning on or off or fading or blinking. So it becomes an output device. So to declare or inform the microcontroller that we are using pin 13 as an output pin, we'll have to select or set the pin mode. To do this, you type pin mode. Please, this is case sensitive, so always be sure to type it the way I have. All right, the first parameter in pin mode is the name of the pin you would like to declare the mode for. So this time it's LED pin, comma, and the mode you want to declare it, it's either going to be an input or an output. For today's class, it's going to be an output because it's an LED, and then we'll bring our semicolon. Then the next thing is to go to the void loop. So the Arduino microcontroller programming or Arduino sketch is divided into two main parts. So we have the void setup part and the void loop part. The void setup part is the section of the code that runs once whenever the microcontroller is restarted. When we get to the void loop part, this is where we write the logic behind what we want to do. In today's class, we would like to blink an LED. So to blink an LED, you would have to turn it on and then turn it off. That's the process, and we'll repeat the process over and over again to get it to blink. However, the microcontroller we are using has a clock frequency of 16 megahertz. What this implies is it does things at a very fast rate. And so if we just set our microcontroller to operate at 16 megahertz without inserting delays in some portions of our code, we'll actually not see the microcontroller taking actions. An instance is seen here. If we are to turn the LED on and turn the LED off without inserting a delay inside the code, we're actually not going to see the LED blinking because the microcontroller will be doing it very fast and our eyes will not be able to perceive it. So to prevent that, we are going to insert a delay. First, how do we turn an LED on? To turn an LED on, we are going to use this function called digital write. And digital write takes two arguments. The first argument is the name of the pin we would like to write to. This time it's called LED pin. And then the second argument becomes the state we want to write to. Is it going to be a high or a low? Do we want to turn it on or we want to turn it off? To turn a pin on, we'll type high. It's high in uppercase. This is going to send 5 volts to the LED pin, which is actually pin 13. And the 5 volt is going to turn the LED on. When we want to turn it off, we are going to write digital write. So we are writing 0 volts to the LED pin, that is pin 13, low. So when we write low, we are sending 0 volts to the pin, the LED pin or pin 13. This should actually be blinking the LED, but because of the high rate of operation or the speed of operation, we will not be able to perceive it with our eyes. So to prevent that, we insert some delay. So let me just insert a delay of 500 milliseconds. So in microcontroller programming also, our time is measured in milliseconds. Okay, so using a delay of 500 milliseconds implies you are delaying the circuit for half a second. So what that means is when we turn our LED on, it is going to stay on for half a second. Then we are going to turn it off, and we are going to ask it to also stay off for half a second. Okay, however, because this entire code we've written is inside a void loop function, this process is going to continue over and over until we turn off our microcontroller. Let's verify this and see if it works. I would have to save it, so let me save it as blink example. All right, so I'm saving my code as blink example, and I'm compiling to see if everything is correct in our code. So compiling may take a while depending on how fast your computer is, but it's usually not that long. And it's usually the first compile or verification that takes a while. The subsequent ones wouldn't. All right. So because we are using a virtual environment, that is Proteus software, to program our microcontroller, we'll have to copy the hex file and feed that hex file to our microcontroller or our virtual Arduino board in Proteus. So to do that, we'll select the file directory to our hex file, copy it, and we'll switch to Proteus. Double click on our Arduino board, click on program file, and paste the file directory there. Now that we have our hex file added to Proteus, we are just going to click on OK and try our code out to see if it will work. So now clicking on this side of the code to start simulating the software, we can actually see our LED blinking, turning on, waiting for half a second, and then going off. So congratulations, you are now an official microcontroller programmer. It's going to be a long journey to get to proficient level where you'll be programming big projects and doing amazing things, but it all begins with this step, trying this for yourself and playing with it as well. All right, so we are going to stop the simulation and then switch back to our Arduino IDE. There's one last concept I would like to introduce before we end this class, and that is commenting. So you may not see the significance of this concept at this moment because this code is very short, brief, and concise. It's simple and you can easily understand. But when you're having chunks of code, it will be difficult for you to remember what every part of the code does. So it is good you insert comments along your code to help you understand what you are doing. So here I'm going to add some comments to this code, and I'm going to comment in Arduino. We use double backslash for a single line comment, and then we use backslash hash. Then to close it, we use hash backslash, sorry, for multiple line commenting. So if you want to comment multiple lines, we use this. If you want to comment for just by a single line, we use the double slash. All right. For now, we are just going to do a single line comment. So let's do that. I'm just going to say assigning LED pin to pin 13. All right. Okay. And I'm just going to add that declaring LED pin as an output pin. And over here, we are just going to add turning on LED. And we're going to say delay for half a second. Then we are going to turn our LED off. So turn off LED. And then we are going to delay for half a second also. Okay, so with this done, we have commented every part of our code. And whenever we pick this example, we should be able to make sense of what we actually meant while writing this code. All right, I believe this was an informative session. If you like this video, please do well to subscribe to our channel, hit the bell notification icon so that you are notified whenever we add new content to the channel. Also, don't forget to comment, try it out, and then let's talk about it in the comment section below. Thank you. Have a wonderful time. Bye-bye.